In this video, we're going to talk about binomial probability distributions and look at how to use Minitab to help us calculate the probability for a particular event. So the first example says approximately 70% of statistics students do their homework in time for it to be collected and graded. Each student does homework independently. In a statistics class of 10 students, what is the probability that at least 4 will do their homework on time? Students are selected randomly. And I want to kind of walk you through a series of questions or kind of the thought process that you would go through in order to kind of answer this question. The first thing you need to do is to ensure that you're dealing with a binomial probability distribution. And to do that, you need to meet 4 different conditions. The first condition is that you have to have a fixed number of trials. So you have to know how many times you're going to perform that particular procedure, or how many are you going to survey. And so in this case, they tell us in the story that we're going to have a class of 10 students. So we do have a fixed number of trials. In this case, our sample size, or N, is going to be 10. You also have to ensure that you have 2 outcomes. And this is more of a think it through process. We're looking at whether a student does their homework in time for it to be collected and graded. So if you think about what options you could have there, they either do it or they do not do it. And so there are 2 outcomes in this scenario, so we're okay there. Thinking about first, if the trials are independent, if you look at whether the trials are independent, it clearly tells us that in the story, because it tells us that each student works independently, meaning they're not working together. What one does is not going to affect another. So we do know that our trials are independent. And if our trials are independent, the probability of success is going to remain constant. And there's no indication here that that the probability is affected by anything. So again, we have that sense that that probability is constant from problem to problem. Then it's helpful to go ahead and identify the information, or identify what I tend to call the players in the problem, because you've got lots of different numbers. We've already talked about that our sample size, or number of trials, is 10. P, remember, represents your probability of success, that you get what you want. In this particular scenario, what we want is the student to do their homework in time for it to be collected and graded. And it tells us in the first sentence that approximately 70% of the students do that. So my probability of success is 70%, which I do need to convert to a decimal. So as a decimal, that's 0.70. Q is the probability of failure. Okay, it's not stated in the problem, but it's something we can calculate because it's 1 minus P, or 1 minus the probability of success. So 1 minus the 0.70 is going to be 0.30, which would be my probability of failure. And X represents your random variable, how many you're looking for. And in this case, that particular number is 4. More specifically, it asks us to find at least 4. Okay, at least 4. And sometimes those words get confusing to students and they are uncertain what they mean. So let's think about what that phrase "at least" means. The phrase "at least," if you think about it from an English perspective, and then thinking about it from a math perspective, at least means you can have that number or more. So when I see that phrase, at least 4, in my mind, I'm thinking 4 or more. So in this case, that means I could have 4 or 5 or 6 or 7 or 8 or 9 or 10, because the total number is to 10. So I can have any of those 7 options there. And notice I kept using the word or, and that's important because mathematically, in relationship to probability, when you think about the word or, that indicates you need to add together the results for each one of those individual values. So we're going to use, because we don't want to do all the hand calculations, that would be 7 different calculations we would have to do, and then perform the addition, so that would be an 8th calculation. We're going to use Minitab to help us calculate this. Okay, so I want to show you how to put this into Minitab first. So you would open up your Minitab to a spreadsheet. In column 1 of the spreadsheet, you would need to put X, which in this case would be the students who do their homework. Okay, and so we need to think about how many students could we have who actually do their homework in time for it to be collected and graded. We know we could have up to 10 because we have 10 students, but it could be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Okay, you have to include 0 because there is the option that nobody does it, and then of course all the way up to 10. So you enter the values of X that are possible from 0 up to N, the total in your sample, and then we need to follow the commands. We're going to calculate, so we go up to the top of the menu and find calc for calculate. I'm going to scroll down to probability distributions, which is what we're talking about, and then I'm going to specifically select binomial. Now be careful, because I want to do just straight out probability, not cumulative. So I'm going to choose the radio button next to probability. The number of trials is N, so that's 10. My event probability, the probability that they did their homework, was the 70% or 0.70. My possible values for X are in column 1, and I want to put my answers in column 2. And then I'm going to click OK. And I get this table. For all intents and purposes, that's what it looks like. The table, column 2, represents the probability of that particular event. Okay, so then I'm going out, and I've copied that table onto my slide, because to find the indicated probability, what we need to do now is we said at least 4, so we could have 4, 5, 6, 7, 8, 9, or 10. So we need to add together, and I'm going to write it out for you so that there's no question about what it is we're doing. We're going to add together 0.036757 plus 0.102919 plus 0.200121 plus plus 0.266828, get that decimal point in there, plus 0.233474 plus 0.121061 plus 0.028 2, 4, 8. We're going to add together the probabilities for 4, 5, 6, 7, 8, 9, and 10. You can use a handheld calculator to do that. So I'm going to do that real quick on my calculator. It's straight out addition. Just be extra careful. Make sure you get the numbers typed in correctly. Notice I did not do any rounding yet. Okay, any kind of rounding we'll do at the last step. Okay, you may want to double check yourself, make sure you put the numbers in there correctly because you don't want to make a mistake. Okay, so I'm double checking real quick to make sure I got them all entered correctly. Don't let something as silly as a typing error. Okay, so when I get all of those added together, this totals 0.989408. And you're typically asked to round to 4 decimal places. So notice that the number 4 is in the 4th place. Next door is the 0, so it stays the same. So my answer is 0.9894. Or if you want it as a percentage, that's about 98.94%. The decimal value is okay because it asked me for the probability. Okay, so there's about a 98.94% chance that at least 4 students will do their homework on time and for it to be graded, turned in and graded. We also need to be able to calculate the mean and the standard deviation for our scenario. Those two things are formula based, okay? And so it's something you'll do on your handheld calculator. If you'll recall, the formula for the mean, the mean of the binomial is simply the mean is the sample size times the probability of success. So in this scenario, that means I would have 10 times 0.70, which would be 7. So we should expect 7 students to do their homework on time for it to be graded and collected. The standard deviation is also a formula base. It is the square root of n times p times q. So we would have the square root of 10, we've already identified these earlier, 0.70, 0.30. And again, this is strictly a handheld calculator calculation. So I would have 10 times 0.7 times 0.3, and I'm going to take the square root. And when I do that, that's 1.449137675. You'll likely be asked to round that to 2 places. This would round to 1.145. All right, let's look at another scenario. A survey found that 25% of pet owners had their pets bathed professionally rather than do it themselves. If 18 pet owners are randomly selected, find the probability that fewer than 5 people have their pets bathed professionally. Again, you got to think through and think about, do we actually have a binomial distribution? So we ask ourselves, do we have a fixed number of trials? And we do, because it says we're going to talk to or randomly select 18 pet owners. So I do have a fixed number of trials here. Okay, so then two outcomes. Again, you got to kind of think about it. Either they have their pet bathed professionally or they don't have it bathed professionally. Okay, so you have to think about that. So there's two options. They either do or they don't, whichever one you think. Okay, let me choose a pen here. So we had the fixed number of trials. We do have two outcomes. Again, you got to kind of think through. It doesn't clearly say independent here, but think about it. What one pet owner does, I don't think would affect what another one does, which means the trials are independent, and therefore my probability of success would be constant because we're not looking at the same pet owners over and over again. Then we identify the players. Again, we are looking at 18 pet owners in total. P is my probability of success, which is telling me 25% of pet owners. Converting that to a decimal, that's 0.25. Q, remember, is 1 minus P. It's a hand calculation. So 1 minus 0.25 is 0.75. And I'm going to do fewer than 5. Okay, and so then let's think about the phrase fewer than. And the main thing you want to think about here with fewer than is, should you include 5 or not include 5? Well, when I think fewer than, I'm thinking it could be 0, 1, 2, 3, 4. That it does not include the number that's stated, because it's saying fewer than. It doesn't say fewer than or equal to. So you want to be less than that. So in this scenario, fewer than would mean fewer than 5 would mean we could have 0, 1, 2, 3, or 4. It doesn't actually include the number. And guys, that's important when you're thinking about these calculations. So again, let's go out to Minitab. We can use a different column on our spreadsheet if we want. So just so we don't get confused, I'm going to go over to column 4, and this is going to be the number of pet owners that have their pet bathed professionally. Again, we can have none, and our total sample goes up to 18. So we have to go from 0 to 18 for our possible values of X. I've entered that. Let me see, make sure I didn't miss one. 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Okay. Then we got to calculate. We calculate, go to Calc, the top of the screen, scroll down to probability distributions, select the specific one we're doing, which is binomial. Again, you want probability. You now have 18 trials. The probability that they have their pet washed professionally is 0.25. Okay. Oh, I got it. Sorry. Is 0.25. We have to choose our input column, which is changed because now we're doing pet owners. And okay. Obviously, Minitab is very particular if you don't enter it correctly. And then we want to put our answers, in this case, column 5, or next to the pet column. So I choose column 5. Click OK. And again, my results, and I'm going to pull this up where you can see it big, my results come up in a table form. And again, I've copied that onto our slideshow so we can see it and talk about it. And again, we want to find the probability of fewer than 5, which we talked about means you want 0, 1, 2, 3, or 4. We do not include the 5. So again, we're going to add those numbers together. So I'm going to write it out so you can have no confusion. So we point 0.05638 plus 0.30332826 plus 0.095841 plus 0.170384. And guys, I would encourage you when you're working on these to do the addition twice, just to double check yourself. Make sure that you don't enter something incorrectly and possibly miss the problem. Okay, so we're going to add using our handheld calculator 0.005638 plus 0.033826 plus 0.095841 plus 0.170384 plus 0.21290. And we enter and we get 0.518669. Again, you're typically asked to round to 4 places. This would round to 0.5187. Okay, so there's about a 52% chance that fewer than 5 pet owners have their pets bathed professionally. Again, we can also calculate the expected number or the mean number of people who have their pets bathed. Again, guys, remember it's strictly a formula. The mean is the sample size times the probability of success. We had 18 pet owners times 25%. So using your handheld calculator, 18 times 0.25 is 4.5. So we would expect 4.5 pet owners to have their pets bathed professionally. The standard deviation, remember, is the square root of n times p times q. So I would have the square root of our sample size, which is 18. Probability of success is 25%. Probability of failure we determined to be 75%. So when we do those calculations, we get 1.8377117307. Again, rounded, probably going to be 1.84. Usually you get 2 places there. Okay, so it's purely a formula, purely a plug it in type formula. Okay, let me walk through one more. It says if 85% of people living in Georgia have internet access from their homes, find the probability that in a sample of 25 people, more than 19 have internet access. So here again, you got to think through the problem, make sure it's a binomial distribution. Do you have a fixed number of trials? And we do, because we have 25 people that we're going to consider. Do you have 2 outcomes? And again, thinking about it, we do, because they either have internet access or they do not have internet access. So there's 2 possibilities. The trials are independent because whether one home has access and another home doesn't shouldn't affect each other, and there's no indication that the probability of success is not constant. So identifying our information, we have that our sample size, the number in our sample, is 25. P, the probability of success, probability that they have the internet, is the 85%. And my tablet is acting up. It doesn't want to stay working for some reason. That's the dingling you keep hearing. Okay, so N, let's try again. N is 25. P is 85% or 0.85. Q would be 1 minus P, which would be 15% or 0.15. And X here is 19. So if you're thinking about, again, thinking about what more than means, more than 19 here, and again, the primary thing you want to think about is, does more than include, in this case, the value of 19? Again, if I think about what that means, to me, when I think about more than, it's going to be not include the 19. So it should be 20, 21, 22, 23, 24. Okay, so you would have basically go from 20 up to our total of 25. Okay, so let me see if I can get these numbers written in here. 25.85. 1 minus 0.85 is 0.15, and X is 19. And again, when I think of more than, it does not include the number. And that's really the primary issue, is should you include, in this case, 19 or not. So in this case, more than 19 to me implies we could have 20, 21, 22, 23, 24, or 25. So let's go out to Minitab. Okay, and we have, okay, I know that. I'm going over to an empty column, and my X in this case is the number of homes that have internet access. And we're looking at 25 homes. I have to remember that could include 0 with internet access. So we have 0, 1, 2, and we go all the way up. Whoops. Watch, put your numbers in. All the way up. 25, because that was how many were in our sample. Once you get those entered, we're ready to calculate. So we go over to the menu bar to calc for calculate. We choose probability distributions. We're talking about a binomial. We want to calculate the probability with 25 trials. We said 85% have access. Make sure you change the column where you're storing your data and your input data. We click OK. And we get this table of values. And again, I've copied those onto our screen so we can talk about it. And we said more than 19. So more than 19 would be 20, 21, 22, 23, 24, all the way down to 25. And again, because you have that option of it being or, we have to add those together. So adding them together, I have 0.156378 plus 0.210986 plus 0.217379 plus 0.160672 plus 0.078, 0.075873 plus 0.017198. Okay, so then we're going to use our handheld calculator. We're going to add those numbers together. Okay, 0.156378 plus 0.210986 plus 217.379 0.160672 plus 0.075873 plus 0.017198. Okay, and I get a value of 0.83. So this equals 0.838486, rounding to 4 places. That would be 8385. So about an 83 to 84% chance that more than 19 homes have internet access. Now, there are other ways to do this. You could do cumulative probabilities within Minitab, but to kind of keep it simple, it's just easy enough if you interpret it and add together the ones that you need to add together. And then finally, again, we can calculate the expected number of people, which is the mean. And remember, the mean is the sample size times the probability of success. So we would have 25 times 0.85. So we would expect 21.25, roughly 21 homes to have internet access. My standard deviation is the square root of n times p times q. Again, guys, these are basic calculator calculations. So n is 25, p is 0.85, q is 0.15. So we do the calculations. And we get 1.785357,107. Again, rounding to 2 places, that's going to be approximately 1.79. Okay, so there gives you an example and a variety of examples related to the binomial probability distribution and the use of Minitab.